wanted to pass on a few tidbits, few hints for looking at doing a graph by hand. One of the first things that you need to do is decide upon a scale for your two axes. And to do that, I'm just going to I just grabbed a piece of graph paper here, and then I just started trying what scale works. And I see here that if you remember my time, that's going to be my x-axis, my temperature, that's going to be my y-axis. And when I look at this, I go, okay, what's my biggest number and what's my smallest number for my temperature? And I see that's ranging from 70 roughly to 180, just a little bit over 180 degrees Fahrenheit. And then I notice that my time, well, that's running from 0 to 25.5. And that was in minutes. What this tells me is I'm going to want to use the longer dimension of my paper for my y-axis because I have a bigger range. That means then, of course, I'll be using the shorter dimension for my x-axis. Let's try some axes, let's try some axes to figure out how we can use at least 2/3 of the height of this paper. The first scale I tried was honestly looking at skipping one line. So there'd be 70, 75, 80, 85, 90, 95, 100, and so on. That one doesn't work because it's too big of a gap. So I went to the other extreme. I went 70, 72, 74, 76, 78, and then 80. So I went up by increments of 2. And if you notice, I ran out of room at 150. Okay. So this one's too small a gap. Okay, so if I can't count by 2s, counting by 0.5 was too big a jump. Counting by 5s was too big. Counting by 2s was too small. Let's go 2.5. Well, I could squeeze it, but it's getting kind of tight. So I had to decide to go with a graphing scale that I really don't like. And the reason why I don't like it is if this is 70, this would be 73 and 1/3. Then I would have 76.67, and then I would have 80. It just makes things more complicated when I go to do my estimations of my points as I'm graphing, as well as doing my doing the slope. I did something very, very similar with my time scale for the x-axis, and what I came up with is a set of axes that look like this. Once again, one of the first things I like to do is, well, if I'm doing a computer graph, I'm going to flat off do the labels first. Here, I'm going to go ahead and go in and put in my data points. So with my time of heating in minutes, and then here I have water temperature. And that's degrees F. Now I'm going to go ahead and use a different color. I have a 0.0 and 73.2. Put in a data point. Next one is 5.4. So I know it's someplace above 5. And if I count my graduations, 5, 6, 7, 8, 9, 10, I know that I'm going to be putting my mark someplace between 5 and 6, a little bit less than halfway. And on the y-axis, I'm looking at 94.2, so something above that first mark, which would be the 93.3. And then I'm just going to keep going. I have 10.2 and 112.7. And now I have 15 and 135.0 and 21.8, 158. And my last one was 25.5, and it's just a skosh, I know, good word, just a skosh over my 180 mark. Is that right? Oops. And see, it always helps to go back and take a look, because I have this at 183 and that makes no sense. So I'd have to come back and go, okay, so it's 25.5, 25.5, and it's just above 180. Well, we'll call it right there. Your next step in your data is to adjust for line. If you can get your hands on a transparent ruler, that helps a lot. So I have a transparent ruler that I have laying over my iPad screen right now, and you will see my best fit line come through. Is it perfect? No, it's not. Is it pretty good? Yeah, it's not too bad. It's not too bad. Okay, so the next thing you're going to want to do with your graph is you're going to want to title it. Again, some kind of descriptive title. So here we could do water temperature. increase as heating time increases. So there you go. Now we need to find our slope. And again, using the computer program, really, really nice because it just goes ahead and does it for us. I'm going to be looking for where this trend line crosses my grid lines. I'm not worried about whether I have an actual data point. I really don't care if I have an actual data point or not. And there I go. Those are my 2 data points that I'm going to pick. And now I'll go ahead and I'll read these off. And I'm going to come across. And I see here, I'm just going to make myself a dashed line. And my Y is 170. .0, and my X also just going to come down, find out where it hits on my axis. Dun, 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 dun. Again, I'm very deliberate. I was very deliberate in which points I picked because I wanted them to hit right on these grid lines to make my life easier now. So I have 20, 21, 22, 24. So I've got 24.0. And then down here, very similar. This is easier. Whoops. This is easier because I'm closer to the axes. And I see that I have this right on 10. And I have 113.3 repeating. Notice that my line of best fit is definitively there, but it's not, sorry, it's not overpowering my data points. My data points are distinct, but again, they're not overpowering the line. You can see them without them being too large. And these dashed lines, I'm just calling out the particular X1, Y1, X2, Y2. The graph, again, I want to make sure that my scale on the y-axis takes up approximately 2/3 of the length of the paper. Same thing on the x-axis. I want to make sure it takes up at least 2/3 of the width of my paper. I'm going to determine a scale, determine the spacing for my tick marks. And once I decide on that, I'm going to be consistent across, in this case, my heating time. I do the same thing coming up. I have determined the graduations I start them and then I continue going up. So I'm going to start my scale below my first data point, and I'm going to end the scale someplace above my last data point. So first thing you need to do, figure out what the scale is that you're going to use on the x-axis. What are you going to do on the y-axis? They don't have to be the same. But once you start with this being 1, 2, 3, 4, 5, you need to maintain that all the way across the axis. Once I've done that, again, I do like to put in my labels for my axes. Full name, I'm okay with abbreviations. Make sure you include units. Find your data points, okay, and then actually plot your data. My best fit line, use straight edges. Use a straight edge, especially since we're going to be using this line to calculate, in the case of the experiment, the density of the solid, whether it was A, B, C, or D. And if you, so A, B, C, or D, or whatever your solid was. Then I'm going to pick my 2 data points on that linear curve. And I'm going to go ahead and find the slope. So the slope equals the change in y over the change in x, y2 minus y1, x2 minus x1. It doesn't matter what you want to call x, what you want to call y. And for my y values, I have 170.0 minus 113.3. And on my x-axis, I had 24 and 10. 24.0 minus 10.0. Now let's do that subtraction. 170 minus 113.3. So for my slope, I have 56.7. And on my y-axis, that's degrees Fahrenheit. On the x-axis, 24 minus 10 is 14. And that's in minutes. Now I can take 56.7, divide by 14. My slope would be 4.05 degrees F per minute.